Before we talk about the kinds of models we're going to be drawing in this class, I want to review the 5 fundamentals of what we mean by object-oriented. So here we don't just mean object-oriented languages, but the kinds of object-oriented programming that you're going to be doing, or maybe just object-oriented thinking, which is different from procedural language thinking. The first concept in OO is that everything is an object. That means that you're not thinking about, for example, a program counter incrementing. You're thinking about an object that exists in memory somewhere, and it's going to be doing something. A program is a bunch of objects sending one another messages. So again, we're not thinking about the increment of a program counter through code as much as having a bunch of objects that are floating around in the memory of our computer. If they decide they want some other object to behave in a certain way, they send that object a message. Each object has its own memory, and that memory is made up of other objects. This again is a departure from the procedural language world, where we may start up in main and malloc a bunch of memory that we're going to be dealing with. So we may allocate an array, and we want to behave in that array somehow in C. In an object-oriented language, whether it's Java, C++, Objective-C, whatever it is, the memory of the system depends on the other objects that are created, and every object has its own memory. Every object also has a type. And this is important because, for the fifth rule, all objects of the same type can receive the same message. So this is important because we want to send messages to other objects, but we want those objects to behave in a way that we expect when we send them that message. And so we're going to refer to objects by type and send instances of objects a message based on the messages that are possible in that type. So everything that we do in terms of object-oriented programming goes back to these 5 fundamental concepts. So I want to point out some keywords that we see in these concepts. The first is object. So objects appear over and over here. We're going to actually look at objects in a critical way when we're doing some modeling for our systems. There are some other keywords as well. Program, for example. That's something that we know how to deal with, for example, in a procedural language, but we can see from these 5 fundamental concepts that we need to think about programs perhaps in a different way. The other is type. In C, we had structs that gave us a way to think in a high level about data, but here we have types that belong to objects, and they're slightly different from structs, as we'll see. And finally, or not finally, I guess, messages. Messages are important because they're how objects communicate, they're how the program executes, is through message passing. And finally, objects have their own memory. So memory is another important concept. So let's take these concepts and list them and think about how we're going to refer to these objects through the various kinds of abstractions that we've seen. So we have here some objects that refer to structure, objects, types, memory. We can, if we pushed pause, for example, we would be able to look at all the objects that exist and the memory that those objects have, and that would give us the state of the system. But that state would be in some kind of a static structure. We also have behavior, which is important. And memory sort of falls both into behavior and into structure here. It's a little bit of a fuzzy line. So the 2 basic kinds of concepts that we have fall either into structure or behavior or perhaps both. And these are where the concepts fit in from those 5 fundamental areas. So now I want to see how would we look at structure and behavior through various kinds of diagrams we might draw. Class diagrams and object diagrams are how we generally will be thinking about structure. We'll also be looking at state diagrams, sequence diagrams, activity diagrams, and use case diagrams. These are the kinds of diagrams that are going to allow us to specify behavior, but we actually decompose behavior into 2 kinds of models: state models and interaction models. So state models are generally composed of state diagrams, and interaction models come from sequence diagrams, activity diagrams, and use case diagrams. So interaction models generally talk about how these objects will be interacting with one another, and also how some external actors, such as someone pushing a button, will cause events to happen. So these are the models of our system, and they map sort of onto the concepts. We see the concepts showing up repeatedly in these diagrams. And the three kinds of models that we'll see, structural models, state models, and interaction models, are what we're going to be covering next.